Hello everyone and welcome back to Chess Game Design with me. So in the last lesson we worked on the king, and as I promised, today we're going to be working on the rook. However, before that I found a bug in our program, which is something that's not supposed to happen in real chess, but it does happen. Let me just demonstrate really quickly. As you can see, I can move this black pawn over this white pawn, so we don't actually want that to happen. The same thing goes for the white pawn. If there was a black pawn here, I would be able to move this pawn to here, even though there would be a pawn there. So to fix that, I've already got the code. I'm going to explain it once I paste it in. So for the black pawn, we need this code. What it does is, along with checking for everything else, we also check that the spot here that's in front of the black pawn has no piece on it. If there is a piece, then it's not going to allow us to move 2 squares forward. Otherwise, it is. So that's this code. I just do it by looking at all squares, the coordinates of row -1, so just looking at that squared, and making sure that there is no piece there, i.e. there are 0 children or 0 pieces in it. Similarly, for white pawn, I do the same, but here instead of -1, I put a +1. And now let's just quickly try it out, restart the game, and it should hopefully work now. If it doesn't, then I am going to need to look into it. So it's white's turn, can't jump over the black pawn, can't take the black pawn, that's good. It's black's turn, can't jump over the white pawn. Good, we have fixed that quickly. So now that we have the black pawn and the white pawn working completely, as well as the knight and the king, let's work on the rook. So the rook script that I have is quite complicated actually. There probably is a much simpler way of doing it, but I wasn't able to figure it out. So this is what I have. What I also did with the rook, you can do it with the knight, black pawn, white pawn, king, and so on as well, was make the changing of color independent of all of the other scripts, so that instead of having it inside of this for each loop, I have it as its own for each loop. So after I make the valid moves list, I just go through it, and for the squares which aren't in it, I make them slightly faded. In my real program, I have done this for all of the pieces. However, I don't think it's that complicated to do. You just need to paste this in and remove this set of the code, and you are done if you want to have it like that. However, I am going to keep both in here so that we have both as an example of what to do. So let's actually explain how the rook script works. Why it's so complicated is because with the rook you have to check that there are pieces, if there are pieces in the way, and the pieces need to stop you if there are. You need to either be able to take the piece and still stop you, or not be able to take the piece but still stop you, depending on whose piece that is. So first of all, what I simply do is the normal checking, which we did in our pseudocode, which is if the square which I'm looking at is on the same row as our rook or the same column, then I add it to valid moves, because the rook can go in a plus shape. So just to make that slightly more visual, I do have it working, as you can see. So the rook can move in like a plus shape. So left, right, up, and down. And that's what this allows us to do. It adds all of those to valid moves. But that, however, does actually include the pieces over each other. So this doesn't do anything with collision just yet. The next bit just helps me out. It doesn't do anything either, but it does help me out later to figure out where I need to stop the rook. So those are the valid moves that it could maybe make, depending on if there are pieces or there aren't pieces. Now what I check here is for the rook if there are pieces in the way. So I'm going through all of the squares again because this is in the same place as this, and if the piece that if the square which I'm looking at is if it fits this criteria, as well as if its row is below the rooks, then I make it equal to check down square, which I have them defined up here. At first I have them as null because they aren't anything at first, normal, which is quite self-explanatory. And here I make it to equal to j. So what this means is, let me just explain it more visually. Once again, seeing as we have the game, I think that it's much easier to explain it using the game. And something like this. So, okay, now it's black's turn actually. I have this white rook here. It finds this piece, and I add that piece to, or I make that square to equal to check down square. So the square which this pawn is on. How I make that is by also checking that there is a piece on the square. So first of all, I check that there's a piece on the square, and then if it's below the rook, I add it to check down square. Now, because I know how my for each loop goes through all squares, I can use that to my advantage, the knowledge of it. So how I'm going through all squares using the for each is from here goes to there, then from here to here, then from here to here, and so on. So it goes from 0, 0 to 0, 7, from 1, 0 to 1, 7, and so on. So left to right and goes up. Which means that the first square that this is going to see is this, or this is going to see is this square. So it's going to make check down square the king. Then it's going to see this one, however it doesn't have any children, so it's not going to enter in here. Then this one same, and then this one. So check down square is going to be in the end set to this pawn. This pawn, because, well, not anything that doesn't fit this criteria is not going to change check down square, and this is the last thing that's going to change it. Next thing I do is check left square. Similarly, I know that now it's going to check this square, then this, then this, then this. In my case, there are no pieces, so this isn't going to be changed. However, say there was a piece over here. It doesn't matter whether it's black or white. When there's a piece there, check left square becomes the square which that piece is on. If there isn't, then it just stays null. I deal with nulls later on, you will see how. Else if, so now it's slightly more complicated, but it's still kinda easy. So I know that it's going to continue scanning from the rook to the right. So the first thing I scan, I want to just stop there and not change check right square. So what I do is, if it's null, and I know it's null at the start, then I want to make it to j. So it sees this square, okay, doesn't enter. It sees this piece, it sees the square. It makes that, it makes check right square equal to the square which this rook is on. And then when it sees the pawn, even though it comes to here, it does enter into this else if statement. When it comes to this, well, check right square isn't null, so it doesn't change it. Similarly for going up. This doesn't fit the criteria, this doesn't, it comes to the pawn. It makes the pawn the check up square. And then it sees the king maybe as well. Or, well, it definitely sees the king, not maybe. But it doesn't change the check up square to that. Because, well, it's not equal to null. So, after we have that, what I do is make a copy of my valid moves. I do this so that I can edit valid moves while looking at it. So you have to have two lists if you want to edit the original one. You can't go through a list and edit it as you are going through it. You just get an error. I've tried it, it doesn't work. I've also copied it using a for each loop. You can't just make one list equal the other because that doesn't work. That's beyond the scope of this lesson. Just look it up. You get pointers basically. You can see what that means in your own time. But you have to use a for each loop and add each element individually using a for each loop, which makes it much easier. Then after you have the copy of valid moves, so I just call it valid moves copy, and I use valid moves copy as well as the valid moves list. I again use another for each loop, so there are quite a lot of for each loops I actually use. There are apparently 4 actually that I can see right now. So I go through valid moves copy this time because I want to edit valid moves. So if you want to edit valid moves, you need to go through valid moves copy. If you want to edit valid moves copy, you need to go through valid moves. You can't go through valid moves and edit valid moves. You get an error, as I mentioned before. So as I go through valid moves copy, I check different things. What dot remove does is it removes the element which, well, the element which you give it here. So J, the certain square that I'm looking at, it just removes it from the list. Because all of our squares are unique, the squares are not there. We have no duplicates, meaning that it's not just going to remove one of them. It's going to remove the correct one that we want to remove. So the things that I check for are there are 3 things I check for. The first thing I check for is that the square which I'm looking at has a child, i.e. has a piece on it, and the piece on it is the same as the piece which I have selected, i.e. if the rook is white and this piece is white, then I want to remove it because I don't want to be able to take my own pieces. So that's the first check I do to remove the piece, the square movement. I don't want to be able to take my own pieces. The next thing I check for, so as you can see I have an OR here. So if any one of these is met, then it removes it. What you could also do, which is what I had at the start but I found it less efficient, is if this, else if this, else if this, and each time just remove, but you don't want to repeat yourself. So doing it with ORs is much better. So that's the first condition. Second condition is check right square doesn't equal null. So I want to, if you don't check for this and it does equal null, then what happens is you get an error over here. So you want to check that it's not null, and if it is null, then it's not the compiler is not even going to check for this. It's just going to exit and not run this if. It's not going to run whatever is in the if because we have an AND here. So if it's not null and the square which I'm looking at is to the right of the square which I said over here, to the piece, to the square which contains the piece which is to the right of the rook. So what I'm saying is, for example, I have this rook here. So this is the rook I have selected and I have another piece there. Oh, what's happened there? Oh, well, it's not supposed to happen. Sometimes weird things happen if you reload the game outside of its environment. So let's just redo that really quickly. There we go. So there's a piece over here. I have set check right square to the square of the piece that this is on. So to the square that the piece is on. And what I'm saying is if the square which I'm looking at is to the right of this rook, then I just want to remove it because you're not supposed to be allowed to move beyond the piece if it's in your way. Hopefully that makes sense. So we are just using this which we got beforehand to make this check, and if that fits, then I just remove it. Similarly with the up direction, I check up square not equals null just to make sure that I can run this, and if check up square, so if the square which I'm looking at is above the piece which I said is allowed to move, so this king is above this pawn, so I'm not allowed to, I should not be allowed to go to that king, capture the king straight away. So if that's true, then I just want to remove it because it's above the pawn. So that's the right and up direction sorted, as well as my own pieces, so I'm not allowed to take my own pieces. Then what I do to make my life easier is valid moves copy.reverse. Remember, valid moves copy has not been changed. It still has all of the original valid moves, which we added over here. Well, not with clear, obviously, but with valid moves over here, which we added. It still has the original ones, so all of them, including the ones which we have removed over here. So I reverse it. That makes it easier because I don't have to repeat a lot of things. I don't exactly know how to explain why I did it, but it's just easier to reverse it. Then I make two new variables, Booleans, found left and found down. So now because I have reversed it, I'm, instead of going from this to this square to this and then from here to here, what I'm doing is actually going from this square to this one, then I'm just going backwards, which makes it easier because from here the first piece I find going this way, if there is a piece there, then I can just stop everything, checking for everything that's on that row, because I know I don't want to be able to go there. That's the easiest way I can explain why I have reversed it. So if I find a piece, I just want to stop the checking in that row or column, depending on what I'm checking, and I use these two booleans to check whether I have found a piece or not. If I have found a piece, then I stop the checking in that row or column. So found left would be the row and found down would be the column. So left and down. Then in another for each loop I have over here, well, we don't need that debug there. I was just testing things because this did actually take me quite a long time to figure out, and there's definitely a more efficient way, I can tell you that. But this is the way I came up with. I'm going through valid moves copy with calling the square J. I just kept it consistent. And if found left, so if that's true, you don't have to say equals true because it's a boolean. I have explained this I think many times in my videos. So if found left, so found left is going to be false. Let's just skip this for now and let's move on to this. So now remember that we're going from right to left with the checking. So we're checking this piece, then this, then this, then this, then this, and so on. And because we are also excluding the pieces which we have already checked using our ifs. So if check left square doesn't equal null, so we're just making sure that we can do the following as we did previously. And the square which we're looking at right now is the square which we said there's a piece on for us that needs to stop our movement. Then found left equals true because, well, we have found the piece that we wanted to find, so we make it true. And if this piece is of the same color as us, so if it's white for the example of this white rook, then we want to remove it from the valid moves because, well, we shouldn't be allowed to take our own pieces once again. I should actually probably do that at the very end using the for each loop which I made previously, but I can improve that later on. That's fine. So that's for left. The same thing for down. If it finds it, then it makes found down true and makes that it removes it if there is a need to remove it, depending on. So if it's my opponent's piece, then it doesn't remove it, so that I can take that piece. However, it does stop my movement from going later on. So once it finds the piece, it goes back into the loop again. And this is where we go back to these. the first if and else if. So now that these are true, say that they are true. So we have this down, we have this spawn over here, which made it true for the down. So let's look at this for the time being. That's true, and the row of the square which we're looking at is less than the row of the square which we said needs to stop us. So we're looking at this square and we're saying that this square is below this square, and because it's below that square we want to remove it because it's below a piece that needs to stop our movement. And I think that that's actually the rook's script explained. This is the best I could come up with. As I said, there probably is a much more efficient way of doing it. I couldn't think of it. And yeah. So if you have any questions, please do feel free to ask in the comments down below, and I would understand if you do have questions. I will be happy to explain them as much as I can. But do rewatch this video as well. Things should come clear once you get the hang of it slightly. Also, copy this code, do some testing, put some debugs in it, and you will see how the flow goes, so that you know when things happen and why. So now our rooks actually work the way we want them to. Black's turn. If you go from here to here, sometimes it bugs, as I said before. And that's not my fault, that's just Unity being that way. That shouldn't have any effect on gameplay in normal terms. There we go. So we can't jump over pieces now. Even if I try to, I can't. Also, as I said, I should probably make one more fix, or make it slightly more efficient. Wherever the checking was with checking for my pieces, which was right here, I can just throw that here as well. So doesn't exactly matter. So for each square j in valid moves, copy once again. If this dot is white equals j dot is white, or j dot piece in square dot is white, then we just want to remove it from the valid list, and we do that by doing valid moves dot remove and j, meaning that now we can just remove these from here, and that should still work. Just to confirm, once it loads, there we go. White's turn, or perhaps not. Okay, maybe we are just going to keep it the way it was, because I need to look into this. This can work, but I need to find out how to make it to work the way I want it to. So I am just going to actually leave it at that. Thank you so much for watching this video, and until next time, goodbye.